embarking on an atomic adventure through history and a dance of humor. Get ready to meet the minds behind the atomic model that shape our understanding of the atom. First in, we have John Dalton, the original atom influencer in the 1800s. Dalton's billiard mode model imagined atom as a solid, indivisible sphere, kind of like an indestructible marble rolling around a simple and elegant structure. But let's not be too gentle about it because it was kind of really unpredictable. Enter J.J. Thomson and his plum pudding model in the 1994. Picture this, Thomson in his kitchen whipping out a bunch of pudding with positive goo-like electrons in it. And last but not the least, scattered like plums. Sweet theory, but it turns out to be a more like scientific desert rather than solid facts. Then, Ernest Rutherford came in 1911 and he said, let's shake things up. He performed the famous Goldberg experiment, and because of that, he was able to deduce the nuclear model of the atom. Imagine, Rutherford is a cosmic bowling, rolling particles at the gold foil. Most pass through, but some bounce back. That kind of reminds me of her, but moving on, like finding out a bowling ball in a giant balloon. It was dense, tiny, and most importantly, a positively charged nucleus. Bohr then took the stage in 1913 with his planetary model. Bohr was the Galileo of atoms, proposing electrons, but the nuclear as a fixed path. Much like the planets around the sun, it was a revolutionary idea, making atomic theory seem a bit more orbital, if you know what I mean, though it was not quite perfect. Now, let's talk about the stage light of the quantum mechanical model, where things get really interesting. Picture this, Werner Heisenberg, by the way that's not a Breaking Bad reference, and Erwin Schrödinger throwing a Rayleigh party of electrons. The dancing floor is an orbital and these electrons are grooved, unpredictable. Thanks to Heisenberg's uncertainty principle. To understand it better, we can say that he had the momentum, but not the position. They're everywhere and nowhere at the same time. This model embodies the weirdness of quantum mechanics, where particles are like waves, the waves are like particles. I know that does not make any sense in the first place, but you will just have to bear with me. Talking about the science team nightclub, moving on. Lastly, let's not forget about Schrödinger's just famous cat, dead and alive at the same time. Kind of like my self-esteem. Moving on, in the quantum superposition, while not directly an atomic model, it's a quirky thought experiment that highlights the bizarre nature of quantum mechanics. It's like saying that your coffee is both hot and cold at the same point until and unless you sip it, and it's kind of retarded thought, but still, we have to just bear with it. So, there you have it. The evolution of atomic models serves as a side of it. Remember, whether it's the billiard mode model, the quantum waves, or the atoms, they will always keep us guessing.